Hello and welcome to Chapter 5, Section 4. This is on side, side, side triangle congruence. If you have three lines of specific length, they will only go together to form one triangle. If you had three random lines like this and you started with one and you attached one to one side, knowing it could go anywhere, and then you took this line and you attached it here, it can only meet exactly this line in one spot and make one triangle. So then we can use side, side, side triangle congruence as a theorem. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. And so if you've got something that looks like ABC and DEF with the little hash marks, you know that the triangles are congruent, not just the sides, but the angles will be as well. If you've got triangle ABC connected to triangle ADC, knowing that line AC equals line AC, not only does the line that connects B and D transect in exactly the middle, because this point is equidistant from here as this point, but that it will match it at a 90-degree angle. So when you have triangles that look like this, when you connect B and D, you end up with a perpendicular bisector, where that one meets, that one meets that one. Try your turn, number 4. Pause here and come back when you're done. Number 4 looks at triangles that are like this, and you know that line AB is congruent to line AD, and line BC is congruent to line angle DC. A is equidistant from B and D. That's what that line means. Because of the converse of the perpendicular bisector theorem, line AC is the perpendicular bisector of line BD, which means that, and that, and that. And because of the definition of reflection, D is an image of B reflected across AC. And when you do this reflection, AC maps onto AC, which makes triangle ABC congruent to triangle ADC. Now, if you need to prove that triangles are congruent using side, 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 if you've got something like this, the proof ends up looking like this. AB equals DE equals 1.7, which makes these two lines congruent. And these two lines are both 2.4, which makes these two lines congruent, and then these two. So because the three sides are congruent, triangle ABC is congruent to triangle DEF by side, side, side. So try B, your turn, 5 and 6. Come back when you're done. B is essentially a repeat of A. Number 5, because line MN is not congruent to line QR, the triangles are not congruent. Number 6, all of the sides are congruent. Therefore, the triangles are congruent by the side, side, side theory. So I'm on Explain 3, Applying Triangle Congruence. Example 3. We want to find the value of x for which you can show the triangles are congruent. So if all you have are the sides, and you know that line CB is congruent to line KL, then the triangles are congruent by side angle side. Now if that's true, then 4x minus 6 equals 3x minus 4, and you need to solve this to make sure that this is true. So I'm going to subtract 3x from both sides, and I'm going to add 6 to both sides, and I end up with x equals 2. So I have come up with a value for x where this can be true. Now when you're looking at this set of application, realize that you could use all three of these that you've learned in this chapter. So pause here and give B a shot and come back when you're done. With B, MN is congruent to PQ and MO is congruent to PR. The question is NO congruent to RQ? And so we're looking at, is 3x minus 11 equal to 4? So if I add 11 to both sides, 3x equals 15, x equals 5. So I can do it if x equals 5. And that's based on the side theorem. So pause here, try your turn number 7, and come back when you're done. With number 7, by the triangle sum theorem, we know that angle H equals 30 and angle T equals 60. So we know then that 7y plus 4 equals 60 because those two are congruent angles. 7y is 56, y equals 8. So we've solved for y, and then because of ASA, G equals U, H equals V, and line GH equals line UV, which both equal 12, which also both should equal 8x minus 12. So when you solve for x, x equals 3. So I've got an x and a y. Pause here and try elaborate numbers 8 and 9. Come back when you're done. Number 8, the class should make 12 sets. The set for 1 is 8 by 8 by 12, and the set number 2 is 12 by 12 by 8. Number 9, the two triangles are congruent if a series of rigid motions maps one triangle onto the other. Your homework tonight is numbers 1 through 27. And then the next night is going to be review for chapter 5, and then the next night is going to be the performance assessments for chapter 5. So let me know if you have any questions and if you feel confident about a chapter 5 quiz. All right? Thanks for watching, and please let me know if you have any questions.